Hello, everybody. I'm working on my accent. I've been 2 years in MIT, but still you can see I'm Israeli. So I want to talk about a curious mind in a versatile body, which is what we're doing in my lab and how does this relate to Meccanoid and how hopefully I'm going to use Meccanoid in my lab. So first, after a poll over with my students, we selected the name George. For obvious reasons, and for those who don't know, yes, everybody knows about Curious George, right? And it's from Boston. I was in the store there. There's a world-class store in Boston about Curious George, and so this is its name. And I decided it wasn't its birthday, it was its make day, because it wasn't born, it was made, it was built. And in the spirit of all the promotion of Meccanoid on YouTube, and also we also did a time lapse of how we constructed it. So here we're starting, and this is me, and this is Omer, my student, and we started. It seems very fast. Jonathan also joined us. Yeah, we're working very fast in the university. Extremely fast, super crazy. And this is Tommy also again. Yeah, we also had wine, because it was like the first time everybody met, and it was really cool. And then the battery ran out, and we changed views. And then this is, what's happening. They're working and I'm talking all the time. So yeah, it repeats for a long time. I'm talking and they're doing things. Hopefully at some point that will work, but yeah. And then 1, 2, 3, pizza cake. Yeah, so we didn't work anymore. We ate pizza. And then they started working again. So that was only the first day because, as people told us, it takes time to build this robot. It's a very, very easy to build robot, and yet it takes a lot of time. There's so many screws. I don't know if you counted how many screws. There are like 1,000 screws or something. It's crazy. So this is the second day, and this is Karen, also a student in our lab. And suddenly you start to see a robot. Up until now, you just see like parts and things. You can't see anything. And then suddenly, whoa, there's a robot here. It's crazy. And it was so exciting to actually see that there is a robot beyond all the screws. And then there's a robot. Yeah, it's crazy. It's actually, yeah. And even more than that, it's working. So I came from MIT, the personal robots group in the media lab, best place in the world, best group in the world, amazing. And I came into the personal robots group, and there wasn't any robot working. So to actually build a robot and see it work immediately is amazing, and it's so satisfying. It never happens. So it was very, very satisfying, and we played with it, and it was a lot of fun. So you can see a lot about, actually, there's actually not a lot there, but never mind. You can go and see things in our website. So my lab is a curiosity lab, so you probably are curious about what is curiosity, because I, as a scientist, like to define things. If you can't define them, you can't research them, you can't do anything with it. So I went to the Webster Dictionary. There are 2 definitions. The first one is the desire to know. We talked about the drive. Okay, this is what you want. But I like this better. It's an interest leading to inquiry. So here you also have inquiry. You also have the behavior. So you need to act in order to be curious. You can't just say, I'm curious, and do nothing. It doesn't work that way. So this is not dictionary. This is me. So I define curiosity as the self-motivated action aimed at learning as much as possible. So there's a lot of things in definition. The first one is self-motivated. It comes from within. It's an intrinsic motivation. You can encourage it or you can squish it, but you can't. It's internal to you. Okay, you can encourage it and you can change it, but it's internal. And for everybody who has any children, they know that they're born curious. This is what they are. They are like curious and trying everything. And you can encourage it and you can change it, but it's self-motivated. And the second thing is also, again, as I said, is that it's an action. So you can't just be curious and not do anything. You need to like go and explore the world, ask questions, and do stuff. And the last thing is learn as much as possible, because for a curious person, for every answer, there's a new question. Not for every question, there's a new answer. If you learn something, you want to use it in order to learn something else. So this is my definition, my actionable definition of curiosity, because this can actually be turned into math. And it can turn into like a computational model. And I won't yet put equations on the board, but I will at some point. So I want to talk about like the computational model we're going to implement. And the reason I'm doing it is that my background is computational. I'm also a physicist. So I work with equation and models, but what I'm going to do in the Curiosity Lab is actually apply these models on people and robots. So I want to study people's curiosity, but using a model, and not just the notion of curiosity, but actually trying to quantify mathematically and model-based quantification of curiosity. And also, obviously, to use robots and make them curious. And the learner is trying to learn something about the robot interaction with the environment, okay? It receives input from its sensors. We heard all about sensors in the previous talk. There's a lot of sensors you can do, and you also act in the world in order to acquire information. So you want to learn this correlation, you want to be able to predict, if I do this, what will happen. This is learning. And the cool thing about curiosity is that the novelty, the things that you learn, are actually rewarding to you. Anybody who experienced the aha moment know that it's exhilarating. It's like eating like really good chocolate. It's amazing when you actually understand something and learn something new. So the novelty here is an intrinsic reward. Again, it's not that someone clapped you or said good job when you learned. It's intrinsic to you. When you learned, you're actually happy. So this is the novelty is now acting as a reward. The critic, which is another component here, actually learns what it does not know. So it's trying to assess, okay, I learned something new. I want to know what I still don't know. Because when I know what I don't know, when I map my uncertain states, when I map this area, I don't know what's happening there, then I can start to change my behavior and go there and explore it. Promised, again, I want to dazzle you with a lot of math. So there's a lot of math here. So everybody asks me about, so I'm telling that I'm quantifying and modeling curiosity. So yes, curiosity is like three coupled differential equations, if you really want to know. This is how you model curiosity. It's a field also known as artificial curiosity, because now we can put this in a robot. The moment you have the math and the computational model, you can put everything that you understood from psychology and from developmental psychology, you can put this in a robot. So I did a lot of studies with other robots, but I want to talk about what I'm going to do with Meccanoid. So I'm going to put all of these models inside the robot and see how it can learn about stuff. So I want to have him have a curious mind. So the point here is that the Meccanoid, it has two amazing features that almost all other robots don't have. The first one is it's human-centric by design. Okay, the whole point of the human, again, I don't know, there are the people who actually did it, but from where I look at it and look at all the YouTubes, the whole point of the robot is the human interaction. It doesn't manipulate, it doesn't follow like a black line on the floor and stuff like that. It's actually all about the human interaction. And as we saw, all the controls and all the things that it has actually all is human-centric. For example, again, there's a stuff called you can recognize faces, recognize the body, and the body reacts, I react, the person reacts to the robot, and the robot reacts to the person. So now the robot can start to try to understand and predict what happens when the person moves, and when I move my hand, what will the person do? I'm trying to learn this interaction, and I'm trying to learn this in a curious way. I want to explore this human-robot interaction in a very methodological and computational manner. So this is one thing which is again very unique to this robot. There aren't a lot of those. And the second one, which is I actually really like, is the curious mind, the versatile body. Because no one here talked yet, but it's actually, you can build whatever you want with it. It's so cool. You can just take off the screws and build something else. So I really want to see what happens when you use extreme realities on the dinosaur. When you do this and suddenly, I don't know what will happen, but it probably will be interesting. But again, you can use now totally different, what's called morphologies. Okay, this can be like other animals and other creatures and other stuff. And now what happens to the people who interact with it? It's still people-centric. It's still human-centric. So the question is how people will now interact with it. So we can now learn how people interact with different forms. Okay? Again, you can have the analogy with animals here. First, how the robot learns about its environment and about the people in it. How the robot will behave in order to explore the people. And also how the people will behave in order to explore the robots. So just to summarize, so the point is to imbue this curiosity into Meccanoid. Okay, to like have this curious mind, to think about it, everybody said congratulations, like it's a baby. Yeah, to actually treat, so let it be a baby, because the baby explores and tries stuff, and it's curious and trying to move and trying to understand how to interact with people and stuff like that. So the whole point is to put curiosity in this robot and see how it learns about itself and about the human around it. So the research I'm planning to do with it is how Meccanoid learns about people Okay, so interact with people and trying to learn about them. I can now measure the people interacting with the robot and see whether people are curious or not. Can I somehow quantify? Somehow can I model the people interacting with the robot using the same algorithms? So this is what I had to say, and thank you. Okay, main menu. Main menu. George?
You have my attention.
Thank you. LIM library. No. Okay. It's my Hebrew accent. You remember someone talked about Hebrew accents? It actually went to sleep, right? Yeah, okay, wake up.
You are in main menu. For a list of commands, LIM library.
Thank you. Okay. Who are you? Who are you?
Hi, I'm George.
Hey, George.
I'm a curious robot. Have you ever asked yourself, what is the meaning of life? Am I alive? Am I? Who am I? Or after fellow human once died, to eat or not to eat? Now the biggest question of all, am I alone?
Thank you. So, yeah. In a minute. For those who didn't listen, it's a curious robot, and the biggest question he asks is he alone in the world? And he discovered he's not, and he's so excited about it. So yeah, that was what we did for this thing, and now we can do all the other things. Someone with a English accent want to work? Main menu. Main menu?
Exiting to main menu.
Motion control.
Motion control.
Dance.
I enjoy hip-hop, even though I am not programmed for hopping.
Yeah. Bon. Exercise. Okay. Yeah. Okay. Okay. Yeah. Thank you. Okay. What else? Kung Fu. I could never tell him. Oh. Okay. Forward. Okay. Close it. Turn around. Turn around.
Initiating turn.
Okay. Else? Something else? Dance.
Initiating ballet demonstration. Sensors detect fun is being had.
Kung Fu. Kung Fu.
Watch closely. This is striking snake.
Tell a joke.
You are in main menu.
It is a joke. You see, it's funny. It is funny. Everybody's laughing. Exactly. Yeah. Okay. Tell a joke. Okay. Okay. That's it, right? Okay. Yeah. Yes. He's excited. You know. Also, like, yeah, he's very excited from the thing. Okay.